Kia ora Year 12. This is the second video where I go through two very slow examples of integration by parts. So in the first video, called Teaching Video 1, this is what we looked at. We did two examples where the technique felt a bit like magic. So somehow we integrated these things that look like they're products, right? And then step 3 was why it works. And that was my proof that involved the product rule, right? So when we differentiate a product, this is what we get. That's v times du by dx, right? So integration by parts works by integrating everything in there with respect to dx. Okay, I'm not going to redo the whole thing, but I just want to jog your memories. And then this thing here turns out to be uv, and then we subtract this from both sides, right? But that formula, as Sam said today in class, was just like the most hideous thing ever. So the best way, I think, to think about integration by parts is to understand that proof once and then just to get on with doing it. Now, as we saw in the first video, the tricky thing about IBP is that you have to make a decision about what to integrate and what to leave. And the best way to get good at doing that is, of course, just do lots and lots of examples. So I'm going to do this video, and then I think I'm going to pick out a few harder A-level questions and just keep doing a series of integration by parts videos. This is a technique that you really, really have to practice. Along the way, you'll do a whole lot of good revision for differentiation. So let's look now, first of all, at example 3, which is this integral here. So remember, one of these things we're going to integrate in both of the terms on this side. So we're going to have this thing here minus this integral here. We have to integrate either x or e to the x. So this one's a bit of a no-brainer. If we integrate x, it gets worse, so we're not going to integrate that. We are going to integrate e to the x, and in the first step, we're going to leave the x alone. In the second step, we're going to integrate e to the x, and we're going to differentiate the x. So what does that get us? Well, step 1 gives us x, and the integral of e to the x is just e to the x. Plus, whoops, sorry, not plus, minus the integral of 1 times e to the x, right? So we've differentiated the x and we've integrated the e to the x dx, which gives me x e to the x minus e to the x. And I'm really sorry for the background noise, but I'm sitting here with the dog asleep on the couch, and she has taken to snoring like really loudly, like she needs to go and see an ENT specialist. So that's that first question done, okay? And you can differentiate that back, and you should do that for some differentiation practice, and you'll see that if you start out with this, you end up getting back to this. Now let's look at the next example, which is called example 4. Let's find some more whiteboard. No, not surprisingly, this one's going to be a little bit harder. We have to decide what to integrate and what to leave. We don't want to integrate this. We're going to get a cubic, that's worse. So we're going to leave this, integrate this, and then differentiate this and integrate this. So you can probably see that we're going to end up doing integration by parts twice over. In the first step, we're going to get x squared, right? So we're leaving this, and we're going to integrate e to the x. So x squared e to the x minus the integral of 2x, right, differentiating this, times e to the x, right, which is again the integral of this dx. Now this is a bit of a pain because we've just done this in example 3. We have to do IBP on this as well. So just be careful with your minus and plus signs. We get x squared e to the x minus, and then off we go again. I'm going to do this again, even though I know we've just done this question. So the 2x is what I'm going to leave and then differentiate, and the e to the x is what I'm going to integrate. Right, so let's go. It's going to be 2x times e to the x minus the integral of 2, that's differentiating this, times e to the x dx. If someone is actually watching this, can you just let me know if you can hear my dog snoring? Because I'm not sure how good the microphone is, but she's really loud. So x squared e to the x minus 2x e to the x, and then here we're going to have plus 2 e to the x plus c. So there you go. So that's two examples, but the step up in here is that with this one here, we recognize that we're doing integration by parts twice over. I'm going to do a mix of some trig stuff and some other stuff in the next video. If you're working through chapter 8, D or E, and you spot any problems that you want done, just flick me an email as usual.